Hello everyone, I am back with another video on probability, and this time we are going to have a look at probability experiments. So I'll first explain what is meant by that term, and after that we will look at the relation between probability experiments and the probability we calculate. Namely, we can use a calculated probability to predict results of experiments, of probability experiments, and conversely, we can find the probability of something by doing probability experiments. And I'll discuss both of those. But first of all, what is a probability experiment? It is basically anything you can do that is where chance plays a role, that is completely determined by chance. So, for instance, the obvious ones are rolling it. Tossing a coin first, rolling a die, but it can be less obvious as well, like asking a random person their birthday. It's completely determined by chance which of the 365, maybe 366 days you get. And it could even be something where you cannot calculate the probability, but it's still determined by chance. For instance, if you drop drawing pins, you have no idea whether it will land on its back or on its side. And that is again determined by probability. So all of those are probability experiments. Now, you may want to know what happens if you do a certain experiment often, but you don't actually want to do it that often. For instance, let's think about rolling a four-sided die. And I want to know what happens if I do that 1,000 times. Then what I start by doing is thinking about what are the probabilities of the outcomes. Well, I have four different outcomes. They're all equally likely. So whether I roll 1 or 2 or 3 or 4, each of them have a 1/4 probability. And how many times do I do the experiment? Well, I do them 1,000 times, so let me just write that down. And then all I have to do is I have to multiply the probability by the amount of attempts that I'm making. So I roll my d4 1,000 times, probability of 1/4 each, which means that I expect about 250 times for each result. Now, if I were to actually try this and roll this die 1,000 times, I'm not going to get exactly 250. But it is going to be pretty close. And that is what that probability tells me. So my probability doesn't tell me that for every 4 rolls it's going to be 1, 2, 3, and 4, but for 1,000 times it does divide itself pretty nicely. And that way we can have an expectation. This is my expected result. So that's the one way, from a probability that I know to the expected results of an experiment. We can also go the other way. Maybe I know, maybe I have done an experiment and I want to know the probabilities that came from it. Now, what is important here is that you need a lot of data. So for instance, in the previous video, I threw 3 coins 40 times, or rather I simulated that. And it gives me a reasonable idea, but it's not very accurate. So we're actually going to need a little more than that. And again, the 1,000 that I used in the previous example is much more accurate. And you'll see the more attempts you do, the closer you get. So suppose I want to know the probabilities of rolling 2 dice. So 2 regular 6-sided dice. And I want to know maybe what is the probability that I roll 7 with 2 of these dice. Well, then here I have a simulation, or rather the results of a simulation where it has been rolled 1,000 times. And I see that 7 occurred 159 times. So if I want to know the probability of rolling a 7, then I divide that 159 by 1,000, the total amount of attempts. And I get 0.159, or 15.9%. And of course, I can also calculate the probability. And if I do that, I would get, well, 6 out of the 36 possible options, I would get 16.7%. So it's not perfect, but it's only 0.8% off. It is very, very close. So this way, from doing a simulation or doing an actual probability experiment, I can get a very close estimate of the probability that I was looking for. And once again, for the dice, I can just calculate it. But in some cases, like the drawing pins, I cannot and I have to rely on my experiments. So that is all I wanted to say about probability experiments today. And now it is time for you to make some predictions.